Okay, finite element analysis, how we can do. Next, step by step instructions. Open ANSYS Workbench. The software for download link will be given in the description for both Creo 7.0 and this ANSYS Workbench, ANSYS package 2020. So opening. Okay, it's getting opening. Opened. So we are going to analyze the force factors. How much force is going to be happen in the bone, stress, strain. So static, structural. Just double click the analysis system, static, structural. Okay, now we are firstly going to insert the engineering data, which means the different materials have different data, elasticity. In this project we are going to three materials: cortical bone, okay, in that cortical bone, isotropic elasticity, okay, Young's modulus and megapascal force. Young's modulus 13,000 megapascal for cortical bone. 0.3 will be the Poisson's ratio. Okay, next is the cancellous bone. Same isotropic elasticity, change it to megapascal, 690. You can see this in the journals. Okay, 0.3, same. Then titanium alloy, isotropic elasticity, megapascal change, and 1,02,000 megapascal, 0.4 Poisson's ratio. So that's all. You can save this data as separate file, export engineering data, you can use it. Okay, later we will do. Then attach the geometry, import geometry file, desktop, and then type of the file IGS. That we are exported in the Creo, no, the assembly file .IGS. Open it. Then right click on this, edit in the design modeler. It will take you to the separate application, design modeler in ANSYS Workbench. It is opening. Okay, opened. Import one. You can rename it as bone, implant and screw. Then click generate. Reading that IGS file and the 5 parts: abutment, abutment screw, implant, cortical bone, cancellous bone is displayed here. Just it will take a moment. This will take 1 to 2 minutes time according to the speed of your RAM and processor what we are using. Until we can see another files also. It's another model. Six into I think 6 into 10 mm implant, abutment white platform, screw, cortical bone, cancellous bone. Okay. I think it has got exported or imported, right? Cancellous bone, implant, abutment screw and cortical bone. You should rename this, okay? First of all, just in short form, it's F2 is rename screw, F2 ABT abutment, F2 implant, then cancellous. Okay, got renamed. Okay, next come to Workbench model. Right click on this, edit in another. Mechanical is the another application which used to finally use it. We are going to see the results of the analysis in this application. Okay, it's got opened. Whatever changes done in the design modeler, it's directly exported to mechanical. Okay, geometry, sorry, here mechanical, it's getting loaded. Transferring part assembly, all the parts will be assembled here with names. What we have done, given the names in the design modeler. Okay, geometry, 5 parts assembled here. Okay, model. Okay, we should first of all units, metric unit, millimeter, kilogram, newton, second, millivolt, milliampere. This is apt for a millimeter assembly. Okay, these are the display factors. Manage views. Okay, if this menus are changed, means just click the reset layout, it will be completely restored to original position. Then we have to map the material, engineering materials to the 3D models. Okay, cancel as mode, cancel as. What we have entered here, we have entered here, no, that will be directly transferred to this. Cancel as mode, implant will be titanium alloy, abutment titanium screw. Once again check it out. When I rotate the mouse ball forward, it will be zoom. Backward means it will be zoom out. Rotate middle click and move the mouse means it will be rotated. Okay, here viewpoints, Z, x-axis. Okay, fully the default orientation. Screw is selected, highlighted here. Then click to titanium, cortical bone. Okay, that's all. Coordinate system that will be assigned by the software itself. Connections, what are all the contacts between the two bones? Contact between the five bodies. Okay, now the cancellous and implant will be frictional because the thread is there now, so frictional. Contact between the cancellous and cortical bone will be bonded or rough, either your choice. Okay, then implant and the abutment will be not bonded, no separation, that's all. Okay, then implant and the screw, it will be without thread. We can, when we apply the frictional contact means it will act as a thread. While giving results, it will give as a presence of threads. Okay, next is the implant and cortical bone. Contact will be friction. Okay, here frictional contact give 0.2. Contact region between abutment and the screw, not bonded. Friction. When we completely tighten the abutment screw, no separation will be there. No, frictionless we can give it. Contact region between the 7 abutment and the cortical bone. No separation. Okay, that's all. Contact is over. Mesh, important factor. The entire model, 5 models will be converted into small elements. According to this, what size will be, we have to assign. Just span angle center to find, that's all. Quality, no inflation, same as controlled by software. Statistics. Okay, static structural, it's a final result file. Insert fixed support. While applying force, the model should not move. It should have a standard support like this. So what are all the axes, what are all the planes should have the support, fixed support? That's selected. One, this one, control, press control and click. Right, apply. Force application. Okay, which geometry you are going to apply the force? this one and this one, apply it. Then how many Newton of forces? 250 we can give. Direction, this direction. Okay, this direction inside. Y-axis negative, you can see the arrow mark now. Okay, that's all. Then in solution, what results would be obtained? Stress 1 versus equivalent, and insert strain, and insert energy. Okay, that's enough. All parameters are completed. Okay, in mesh control, here 0.1 mm, right? Least mesh. Next is right click on it, then generate mesh. Okay, the model is completely divided into fine elements. You can see below cortical bone. Just hide it. You can see the small elements. Okay, just hide, and you can see okay, show all the bodies. Okay, next is the solution. Click the solve. That's it. The entire model will be solved by these factors: force and fixed support. Then result will be written here by different color graphs. You can see it will take time, around 5 minutes. Okay, okay, the solving was completed. Equivalent stress we can note here. Okay, all within the limit, very limited stress in the axial load. This load in the y-axis. Okay, we can see part by part also. We can hide the body as noted before. Screw hide, right. You can play the animation here. We can notice the differential changes while loading. Okay, next is the sectioning of the model. Here click this. Here we can split into half, and we can see inside the cavity with the bone drilled space. We can see the cavity. Now show body. Implant will be halfly splitted. Abutment, show, screw, wherever we can see. Let's play the animation. Because the elastic strain can be seen. Let's stop this. And the keyframe animation menu will be there. Then show the screw. You can see this. Okay. Elastic strain. Okay, that's all about the in the axial load in this y direction. We can next we can apply in the z direction mesial loading. Okay. Just unmark the section plane, it will completely show. Okay, we can duplicate this result also. Before that we should save the project where it is same. 3D FEA implant and mandibular bone. Okay, saved. Saving completely. Okay, now we can duplicate this result, static structural. This is the axial load. Next is we can change the load protocol, mesio-distal. Okay, so in the model setup, edit, just close the design model, both will be closed. This another file will be opened. Okay, the same will be loaded. Same mesh, but force can be changed. Direction. Force, same force. Direction. Mesio-distal means this direction. Okay, mesio-distal or disto-mesial, both itself. Otherwise it will convert to negative, means this direction. So force is applied in the mesio-distal direction in the abutment surface. Geometry is same geometry. Apply. Okay. So force is set and solve. That's all. It will take 5 minutes for total solving. Okay, and to see the readings where the stress, what's the value is. result, you can take the probe and you can click it here, 4.83 mega. Okay, and to see the readings where the stress, what's the value means, result, you can take the probe and you can click it here, 4.83 megapascal in the apical region and 3.2 in the middle region, and in the apex, in the cortical bone 60 point. Equivalent stress. Strain means you can mark it here, here and here. E power minus 3, e power 003 means 10 power minus 3. Okay, that's all. It's a way of taking readings. Okay, the mesiodistal load was solved. You can see the result here. This is a half plane. Okay, playing the animation. You can see the stress formation in the bone, movement of the bone, especially cancellous bone, and stress formation in the strain formation in the stress in the abutment screw. Okay. Okay. Now we can hide the implant abutment screw. See the strain formation, especially stress in the bone. Okay. That's about dental FEA and implant show all bodies. Okay, thank you for watching. Please leave your comment in the comment box, subscribe my channel and share my videos. Thank you.